I got, am I correct? True, true, false, false. I got true, true, true. True, false, true, false, true, false, true, false. So it starts like this. Divide them by 2. Divide them by 4. Eight over 2, 4. So I got, and 8 over 4, 2. So I got 2, 2. And 8 over 8 is 1. Okay. So I got Q and R. Okay, this is get Q and R. Q and R. I got, there has to be one, they has to be all true, so this is true. Q and R. Q and R. R. Remember, not all the 3. So I got true, 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 false, true, false. So I got false, false, and I got false, false as well, and false, 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 false. Got 8, 1, 2, 3. That's 8. Or B. Or P. So I got this or P. This true, true. Oh my god. True. I got true, false. True. I got true, false, true, false, true. Got false, false, false. Got true, false. Wait, where am I? How many? 4. 1, 2, 3, 4. Oh my god. True, true, true. False, true, true. True, false, true. False, false, false. True, false, true. False, false, false. Where are we? True, false, true. False, false, false. How many ones? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Not P. Just have to flip them. I got false, 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 true, false, true, false, true. Okay, is this equal to not Q, not R? So not Q is gonna be, let's do the mirror, false, 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 true, 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 true. It's 4. And then I got false, 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 true, true. I got false, false, true, true. And then I got false, true, false, true, false, true, false, true. And then I got not R. What did we start with? Q, R, Q. Oh my God. Not Q, not R, not P. So I got OR, Q and R, FF, false, is OR. I got FF, false, got FT, true, got FT, true, I got T, false, true, I got T, false, true. How many ones? 1, 2, 3, 4, 5, 6. 6, I got 2 left, so I'm gonna go with from the NTT is true, NTT is true. Am I correct? True, 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 false, false. Okay, and P, and P, and not P. So I got false, starting, false, false, true, false. This is not. How many ones do I have? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Okay, from the start. The OR and them. I got FF, true F, F. I got FT, false, TT, true. I got FT, false. I got 2T, true. I got FT, false. And I got TT, true. So what am I having? Is it equal to this? FF, 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 TT, F, F, T, T, F, F, T, T. It's equal. So I got this right. Let's do the other one. Oh my God. Okay. Is there a stand over there? Delete stroke. Delete stroke. I got this right. right? Yep. True. True, they are equal. So what do we have? This one. I should have left. Can I undo that? Can I undo? My fucking. Oh my god. So what do I have? What do I have? Is it the same? The same. So what am I having? I have this. And this I don't need. This I don't need. This I don't need. This I don't need. This is what I need. I got not the same. This one the same as this. Ah, the signs are different. See, the signs are different. Signs are different, so I have to do it again. So I'm going to start here. I got Q or R. So let's start. Q or R. Q or R. Got Q or R. True. 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 False. False. Okay. What else do I have? Got and P. And P. And P. True. False. True. False. Where are we? 1, 2, 3, 4. Okay. This is 4. Here I got true. True. Got false. Oh my god, this is confusing a bit. What am I have left? True. False. False. Wait. True. False. True. False. True. False. 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 So, I got that. What am I having? Not. I got false, true, false, true, false, true, true, true. Then I have here. Got that. I have here the not, the or, or, Q and R, or, false, false, true, true. Where are we? True, 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 true. And then I get also true, true. Am I correct? I got 8 here. I get 8. 2, 3, 4, 5, 6, 7, 8. Get them true, 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 true. So where are we? Number 4. 1, 2, 3, 4. This is true. True. So we get true, true, false, false. Okay. I got the or as well. I got the second or not P. Okay. Or not P. I got false, false, true, 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 true. Wait. Let's check it. So I got or not B. Am I correct? Or not B? B I get T false, T, get T, fourth, T false, T, I got T, 1, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. So I got this T, and I get the TFT, get the, that's, get it wrong, FT is T, it's actually T, and this is FF. So this is wrong. So this is wrong. This is correct. Yep, that's about it. Can you read it? Can you read it? Otherwise, I'm not gonna know. what was it? ft 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 dt open ft 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 dt not equal if tt if 1 2 3 4 5 6 where are you? Where are you? So I get that. Where did I go wrong? First one. So this is true. True. It's not V, not this one. Other one. Not BB, not QB. If and the rest is true. If and the rest is true. So here, where did I go wrong? And P. Mm, T. Q now. V or TT, TF, TF. Nope. What do you mean? QRP. FTTT. TFT. FTT. Yep. There. TTT. TTT. False. TTT. YF. Q is R. And T. No? You got it wrong. True. FF. So, spotted the mistake there. P and you got it wrong here. And TF, FF. TF, FF. Okay, this we have checked. This we have checked. What do we have? The RV. Yep. Here, which is the first part of the equation here. Second part of the equation, got QVR, FF, TT, TT. Yep. Or the P, not the P, or the P. Yeah. F, true. Okay. You got one tiny mistake where in left HS QVR FT you got 3 F total where you got only 2 from down up. Great, something people can under here. Okay, we gotta start the next round. And we got here. Okay. Wait, is he gonna change everything? Alright, I had extra. Actually, 1 still mismatch the same. Wait. Did you change the FT, F the rest is T? correct. Let's T, 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 T. 3 T's, F, T, T, F, F. I have to compare it to mine. Oh, fuck. F, F, F. Then you got the next one is PNR, TF, 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 FF, TF, 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 FT, FT. That's the first one. Second row, you got or FF, T, 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 FF, T, 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 or store, FF, T, second, F, T, T, T. Shut the fuck up, asshole. Okay. Okay. We got problem 3, these I think problem 3. These are problem 3. Just do problem 2, 3, and 4. 2, 3, and 4. 3. The binary logical convection. Connective and or and implies appear often in not only computer programs, so in everyday speech. Computer chip designs, however, it is considerably easier to construct these out of another operation. NAND, which is simpler to represent in circuit, here is the truth table for NAND. False, P and N, which is simpler to represent in circuit. Here's the truth table for. Okay, now true, 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 false, false, true, true, false, false, true. So it's not and, not and. This is not and. So and is going to be true and the rest is false. This is not and. The rest is true and okay. A, B, C. Oh my god. Okay, guys, I'm gonna have to eat first. Relax, baby. Let's check the armor. Skip ones. Temperature 83. Oh yeah, that's too much CPU. Okay, I'm gonna have to go and have a bit of food. I have to let you go, guys. Sorry. Yeah. Using only NAND. Not. So let's grouping parentheses to specify the order in which the operations apply. Here's A, B, there's A and B. Not. Not and and not NAND. So this is not NAND. Not NAND, how is it gonna be? NAND, true, false. So this is not NAND. This. No, god damn it. Not NAND. Using only NAND and not NAND. We can't use not NAND. Not NAND. again. Can't use it. So we got A and B. This is A and B. If not, okay, not A. Not A is gonna be false, false, true, true. Not P. Not Q. False, false. I got here F, true, 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 false, F, true, F, true, and it's gonna be only 2 T, not false, false, false. So NAND, so not P, NAND, not P, NAND, not Q, equal true, 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 false, which is not what we're looking for. Wait, what was I? Should be true, false. Should be true, false, false, false. That didn't. Using only, find an equivalent expression. Using only NAND and not. So this didn't work. Giving them not, and we'll give this, and then I'll give this, and we're looking for true, false, false, false. I'm not sure that I get this right, but the binary and or it implies appear often in not only computer but also everyday speech. Computer chip designs, however, it is considerably easier to construct these out of operation. NAND, which is simpler to represent in a circuit, here's the truth table for NAND. which is not and. I'm not and. Equivalent. Or B. A or B. Okay. Here and equal true, false, 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 and or equal true, 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 false. So what do we have? And and here and equal it's already there. I have this and or equal if true, 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 if true, true, true. So and of this is where we get it. So we'd say not P not Q. NAND. How to say NAND? How to make it NAND? It is this, but NAND. Let's check this. what? We just flipped it, and it's the V, and we just flipped it. Am I correct? So what is it? It's not gonna be A. I need to flip this, but how to write it? And well, always true, and this it's false. Not gonna cut it. Always true, this it's true. So, but here it's gonna be again with the end. It's gonna give me false. 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 Again. It's gonna give me true, 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 false. It's gonna give me true, true, true. No, true, false. Cut it. It's gonna give me true, true, true. Incorrect. All of it true. False. True. True. true, So what I need is true, true. I need it in stop. True, true, false. So yeah, it's right there in front of you. True, true is false. So it's gonna and false, false is true. So it's gonna be and, and P and Q. So this, which is if true, 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 it's gonna be if and if is true. Here you go. And true and true, which is here. Is false, true and true is false, true and true is false. So this one is minus, no, sorry, not P or not Q, and P and Q. Let's check this out. We call it the problem restricts you to only use NaN. No other operations you has sitting in, which technically breaks that rule even though the match checks out. Here is a nudge rather than the fix. Think back to the truth table definition of NaN. You were just given every row except when both P and Q are true. Compare that definition to what actually computes on a truth table. Do they look like they might already be same thing in disguise? They are. That means your whole vertical group could collapse into something much shorter. Is correct. Yeah. So this cannot be used. This one actually, this one cannot be used. So think again. Actually, it is same as this. So what this actually means or let's keep it, is that this one is P and Q. That it says here. This one is P and Q. So what do we have in A or P? We need the OR, you see. T, 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 if what are we having? This one. The same. So we have not P. Oh, sorry. Don't do this. Don't do this. Don't do this ever again. And this actually is not P and fuck off. And not P. And here it's A again. It's A. And A implies B. This is only false when it's true and not false. So here we got P implies Q. Got true. Got true, false. We got the rest true. It's only when this is true and this is false that it is false. So what it says here, lines B, TFTT, TFTT. So what are we having? None when always it's okay. So not as easy as the second one, but you get the drift. We can't use the OR here, so here we don't need the OR. Can't use the OR. We need TFTT. So we got T and it's gonna be only it's gonna go true, false. It's not what we're looking at. Wait, there's something wrong with it. Choose TTT if or yeah, or is TTTF. TTTF. So this is correct. This one has to be TTTT because here it's gonna be what are we having? True and false. Yep. So here it's only false when it's where's the false? When it's true. So it's gonna be false. True and false. It's gonna be true and true, false, true and true. Wait. Here it's gonna be true, but the rest it's gonna be true and true, which is false, true and true. So here is gonna be true and true, false and true, false and true. I don't get it. How am I getting this? It's this against this. The first is false and false. Yeah, we don't need this. The first one is false and false, which is true. And the second ones are true and true, which is false. So this is correct. Checks out. Let's see the implies. TFTT. TFTT. I need the TFTT. And I cannot use anything but the and the not. So what are we having? We got the and only checks if it's to truth. So which means this is true, but this is false, and this is false, and this is false. That's that. I need the TFTT. TFTT. I can't use the OR. So I get here and false, if false, if false, false. Got them all false. With the and here. All false. What do I have? FT. So the nets, I need this. This is true. Yep. That's cute. Here it's gonna be false. And the rest is gonna be true. So it's gonna be not Q, and this bit here. So if NAND only checks false when it's true, true. In this case, here, true, true. And the rest is true. So it's gonna be mine, not P. Oh my god. This bin is gonna get me insane. Get not P, and what are we having? Not A, and not B. I need this to be clear for the AI. So I have not A and Q. Yep. So check this out. How about this? How about now? Check it all, baby, check it all. I have to stop here. Checks out, nice work. Thank you very much, baby. Oh, I did it. Yeah. Here's the last exercise for discrete math today. How many parts do you have still? O, B, and C. So it's actually possible to express each of the above using only NAND without needing to use not find an equivalent expression or not A using only NAND and grouping parentheses. Using only NAND and grouping parentheses. Not A. Using only NAND. So I got not A is this one, FF true, FF true, I only NAND. Can't use even A. NAND and grouping parentheses. I need it to be FF, TT. FF and TT. True. It's not gonna cut it. It's true. 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 False. True. It's not gonna cut it. You can't use the AND. We can't use the AND. Only NAND. True, false, false, false. True, false, false, false. True, false, 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 false. Okay. And I need what? True and true. It's false. I get true and false. It's true. It's true. get true and true. That's false. I got false and true. But this is true. Are you correct? I can only use NAND. So what do I have? I can't use NAND. So I got NAND. This is going to be true, false, false, false. So I got true and true, which is false. I got false and true. No. Yep. It's false and false. False and false, which is true. It's not gonna cut it. I can't use AND. Okay. True with true. It's false. True, true. True, true and false. It's true, that's not gonna get it. So let's just write it here. True, false, false, false. So what else do I need? I need, can't use AND. It's gonna be NAND again. Okay, this and this. This and this. This NAND this. This is gonna be true. True and false. It's true. False and true. That's true. False and true. That's true. Got 40s. Yeah. 40s. This is NAND 1. Got 40s and I got here. Got 40s. This is it, and this. It's not gonna cut it because it's gonna be true. False. 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 False, which is not gonna cut it. Here also it's gonna be false. True. True. True, so it's not gonna cut it. The T is gonna be false, false, true, true. So I got, okay, I have to run this. This is, okay, this is 3. So this is 3 and 3. And this is, what is this? and which is getting called here 4, and this is this true, which is, do you get it? Which is all because never true, so this is 3 A and 4. So what are we having here is, and this is, we're gonna call it 5, and we have 6. Here is if we take this, here is going to be false, true. Am I correct? True and true, false. So this is it. 6 and A. So what we're having here is, we're gonna say A and B, A and B, and what is it gonna be? This is the same, A and B, A and B. This is all in a parenthesis. 3 and 4. So this one, which is the parentheses, and itself, and itself, and itself, and where is it gonna be? And itself, A and B, and A and B. Oh my god. Oh my god. Oh my god. Twice. Can we say twice? I have to give it smaller and writing. So let's check. A and P. And A and P. A, NAND, P, okay, NAND, A, P, okay. This is all NAND, A. Am I correct? 6, which is P. So I'm gonna check false, false, true, true. Which is false, false, true, true. So let's check this out. Okay. B is value at all. A, so here's a quick sanity check. Wait, no, don't tell me the answer. Oh yeah, it's actually possible to express E using only N without needing to use not equal or not A, using only NaN and grouping parentheses. So this one is only this one, and we need it to be this one. So, okay. Five actually. Let's keep our work. So we got this and this. So P, okay, I can't use it. NAND P, can't use the not. So P, NAND P, P, NAND P equal true, true, false, true, true, false, 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 true, false, false, true. The answer is easy, huh? So it's gonna be A, NAND A. Okay, the constant true, false, and false themselves may be expressed using only NAND. The constants true, false themselves may be expressed using only NAND. Construct an expression using an arbitrary statement A and NAND that evaluates to true regardless of whether A is true or false. Construct a second expression that always evaluates to false. Do not use the constants true and false themselves in your statements. Wait, what? The constants true and false themselves may be expressed using only NAND construct and using only NAND. Construct an expression using an arbitrary statement A and NAND that evaluates to true regardless of whether A is true or false. Okay, so let's section A to true regardless of whether A is true or false. So what we need is for them is not to become true. It's always gonna be false. So, okay. So it's gonna be A, NAND A. It's always gonna be false though. A, which is false. It's gonna go with true. It's false. It's gonna go with false. This is false. Or maybe meaning true. So, yep, it is it. So, here, I'm gonna say A, NAND A, NAND A. It's gonna be true. It's gonna be true. So it's gonna be true. 9. It's gonna be false. It's gonna be true. NAND itself and A, NAND A, NAND A. So here it's gonna be always false because it's false. Am I correct? Here it's gonna be look true. So this is gonna be true. True. And itself, true. False. Okay. So that's checks A, NAND A, NAND A, NAND A, NAND A, NAND. Okay, so this is correct. Okay, what's the next one? And A, and then that evaluates to true regardless of whether A is true or false. So this is gonna be all false, false, false. That always evaluates to false. Do not use the constants true and false. Interesting. It's always, so it's gonna be true, 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 true. But it's gonna be true and false. Gonna be, it's not gonna work. Okay, the second part is not gonna work. Because look, false, true and true is always false. Okay, no, but we got it all. What we have is true, 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 and then we got them false, 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 because whatever false is, it's gonna be true. It's gonna be true. But here, but to be false, it has to be true and true. There is no way. There is no way. If this is false or true, once again, zero is to false. Stands results in your statements. Okay. Always evaluate to false. It has to be true and true. There's no way. True, regardless whether A is true or false. So this, we got it here. We got them all false, so it's gonna be true no matter what. Okay, let's check this out. Let me check this. What to run to check to enter pathways is actually a well-known and identity. There's one curve. So mark can be first. Confirmed, correct. For C, you've written one expression. Since it's the same block, simplifies is trace with only true what there is, then you'll have all is. So what you built is a valid, false, constant expression. But the problem asks for two expressions, always true and one that always false, only given the false. Can you build a true always expression to your most the way there? Adjust the middle step you found. You named it with its own. Wait. Given that this is false in every row, it's going to be true no matter what a NAND is false or true because NAND gives true only when there is two truths. So the next one, it wants to be true. How's that even possible? Am I getting this question right? You've got the N3 only one case. Both inputs are true. True everywhere else, including both. It's the opposite. Now, back to was evaluates to T, regardless of whether A is T or F. That's the key point. So, almost when you compute your so negative false. So x and NAND reasoning chain is a constant t, no matter what a is. The expression if so, yep, I am just wondering about the second part, where is it going to give false, no matter where, or no matter whether it's true, false, as well. It's not possible. No, asking about the question itself. I haven't solved it yet, but it is not possible to make the answer always false unless if there is if using NAND. What did you say? What are you talking about? Did I? false, 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 false. ويبقى علينا what does you want? It's gonna be true, 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 true. What did we do? True, 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 true. Answer to false. False. So it's gonna be you want it to be false. So all this means it's true. It's gonna be true, 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 false, false. Yeah, it's gonna be true. No way. No way. I'm not getting the question correct. No way. Are you hearing yourself? Maybe? True. Regardless. So, yeah, this is it. This is the false one. This is the false one. Am I correct? This is the false one. A and A and itself. Then we made it all true. We made it all true. So with true, with wherever, we made it all true. We made it all true. Right. So, and we named it to a false. So it became all false. So it became all false. We named it to all true here. And A, all true. So, and we named it again to all false. So it became all false. Wait. A and A. It's fucking confusing. FFTT. Nan A. So it's become true, 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 true. So it's always true. And then we named it to all true, so it's become false. It's false. So it's always false. It's always false. I told you I'm getting the question wrong. So it's this part. And then this gets false, all false. Which means yeah, I'm getting the question. A and A and A. It's gonna give me false. It's gonna give me all true. NAND A NAND A, which is this one, is gonna give me always true, no matter, no, yes, no, yes, it's gonna give me always true. It's gonna give me always true, because true, false, true, false, true, false, true, true, false, true, true. So it's gonna give me always. Actually, then the message, right? So let's real values. True, true. Lies. Actual values. X comes out, X comes out T both times, even though A itself flips between T and F. X both times. X equal it's between T and A. X doesn't care. X and 2T regardless. That's the whole trick. X isn't testing A's value in a way that lets A flip, show through the intermediate steps, cancel that dependency out. Since X is always T, less of A with F, then X and X is all regardless. It's true regardless of A. Regardless of A, X and always true. It's F. Then X and X. Since X is always true regardless of A, X and X is always true. True NAND T. Always T NAND T, which is always false. So if the F, no matter A, isn't coming from directly with something, it's coming from first building expression they looked into a constant. Then NANDing that constant with itself, you're not fighting A's variable at the last step. It's there. If it still feels like possible, try think out X's full truth table use. Just 2 rows. My answer to the first part is correct because it's all if. Now, if we NAND it with any A in any way, shape, or form, it's always going to give true. So that's what I meant, or what I understood. Right? Or you just found a constant. Anything gives true. What that anything is with. Say, so it doesn't matter. Only false inputs are true. If one input is false, that condition can never be met. So the result is automatically T. Constant. If then T is true, if and if is true, both land on T of A value. It's exactly with X just from the direction now. So you identified two really trick facts: constant true, NAND with itself false. Constant true NAND with itself false. T NAND T is the one case and fails. Constant false and with anything equal true can never hit the both condition. Are legitimate ways to reason about this. You're solid in part C, you've got constant true. Constant justified to wait. So my question, how are you so dumb? My question is, does the same condition in part 1 applies to part 2, whether A is true or false. Yes, the same condition applies. And let's confirm it the same way we did. Your first expression is A, then A, and that's X, and A. Okay? Test it. Test A equal T. You already found X equal T. So X and X. Let's test A equal T. Found X equal T. Not X not equal T. Okay. Test A equal T. Already found X T format. So X and X equal T and T false. Test A equal false. So X equal T. Both cases give. So yes, the first is also constant. So whether A is false. Exactly like this. What are you talking about? What second one? The constant true or false may express using construct an expression using them. A and NAND that evaluates to true regardless of whether A is true or false. So now we get this. He doesn't get it, huh? Gets in the question. Evaluate to false. To use the constants true and false themselves in your statement. Now this is always I'll take it anyways because that's not possible. He doesn't get my question, but it's I know now what the question means because A and A is false is true. That is true regardless of whether A is true or false. So that's so this is A and A is always true, and NAND A is always false. This is what he means by the question. You should divide them. So the first question is here, let's say NAND A, NAND A, always the true. This is 1. This is 2. And this is what he means by it. Alright, so problem 4, you have 12 coins and a balance scale. You have 12 coins and a balance scale, one of which is fake. 12 coins and a balance scale, which is fake. All the real coins weigh the same time. Weigh the same, but the fake coin weigh less than the rest. All the coins visually appear the same, and the difference in weight is imperceptible to your senses. In at most three weighings, give a strategy that detects the fake coin. Note the scale in this problem is a scale with two dishes, which tips towards the side that is heavier. Towards the side